All right. Today we're going to be talking about our platform Convirgance, which we think is a revolution in database access. So real quick, Mary, already mentioned a lot of this. This is me. I've been doing Java since 96, 1.1. I was an active participant in the early Java development and Java adoption through Java Lobby. And one of the things that we were trying to solve at that time was we really wanted transparent persistence to data stores. And so we were working on ORMs at the time, and I was one of the people experimenting with that. And we didn't realize at the time it was never going to work. We ended up with the ORMs that we have today out of that work, where we just kind of got so far and we gave up. And it was never going to work because of something we'll talk about later, the object relational impedance mismatch. So I went on to architect many extreme scale systems in healthcare and finance. And then after doing that for a while, I went in consulting for a couple of years, and then out of that founded Invirgance with the idea of changing the way that software is delivered. So that's what we're going to talk about today. And yes, I did lose Java 4K game programming contest to Notch, Marcus Pearson. It was a technicality, but he won with minors 4K. So best loss ever, because might not have had Minecraft if that had happened. So as we go through this, I want you to keep in mind what we do is very, very, very hard. When we're engineering software, we're supposed to take what's very, very hard and make it look easy. And that's a really important thing that is often missed, that we go, oh, well, that's easy. Well, no, you're missing everything that was behind it. But I'm mentioning software engineering, and it's got kind of a bad rap. I'm sure many of you have said, well, yeah, I've got the title of software engineer, but I don't really do any engineering, right? But software engineering is a thing. It was coined by this lady here, Margaret Hamilton. She worked on a little project called the Saturn V Moon Project, landing people on the moon. And she used software engineering to describe software and systems that are engineered for a purpose rather than just written, right? We typically think of writing software as like an authorship, like writing a book. But really what we need to do is look at the various components of the system, think about what the limits are, and balance the components of the system to come up with an engineered solution. And that's what Margaret did. She designed the real-time scheduler for the Apollo spacecraft computer. And the Apollo spacecraft computer, if you don't know, it was like discrete components welded onto a board. And I said welded, not soldered. Literally, you could see the transistors and the little loops of memory welded onto the board. And so this thing had performance in the kilohertz range. It did not have a lot of compute time, and it had to get the astronauts safely onto the moon. And during the descent, so part of what she did is she engineered a fallback procedure in case the computer ended up with more work that it could handle in the available amount of compute time for the computer. And due to a last-minute change in the procedure, the Apollo guidance computer actually ended up overloaded and triggered the master alarm. So they decided to keep a radar lock on the Apollo command module in case there needed to be an abort. And Hamilton's procedures kicked in, and mission control was able to say, "You're a go, you're fine." What her procedures did was anything that wasn't absolutely critical to taking in the telemetry and updating the trajectory, it pushed it aside and didn't worry about whether it was able to make it or not. And so, she literally saved the lives of Neil Armstrong and Buzz Aldrin. So we're going to be doing some software engineering today. So hopefully, you guys will have an opportunity to learn some things and join me on this journey. But we first have to ask the question, do we need another database access API, right? We've got so many of them. So the story of the convergence technology started about 17 years ago, and it started with a wedding ring. I wish this was a happy story. It's not. Unfortunately, that wedding ring was getting thrown at me. We'd been in crunch time for about 2 weeks at that point, where we were working nights and weekends, my colleagues and I, nonstop. And our families had had enough of it. at that point, I made a promise to myself that that's never going to happen again. I'm going to figure out this crunch time thing and figure out how we can solve it. And, technology is only half of what I eventually learned, but it is an important half of it. So this progressed into a problem, when dust settled, looked into, a problem that we'd saw where we'd run these queries in dev, and then we'd pre-run them in production, make sure that they were fast, and then we'd ship the code to production, and the code would be slow. And we couldn't figure out why. It was the darndest thing. And then eventually, I tripped upon that when we were testing the queries, we were replacing the bind values with the actual values. And it turns out the optimizer in the database, it makes a huge difference. So that was a big learning. Well, so we were using Hibernate at the time, so I hacked it up so that it would inject these values. And that initially worked, but it wasn't good enough. And plus we were maintaining this hacked up version on the side. That wasn't great. So I started diving deeper, and I found about 60% of the code was just ORM boilerplate. It was POJOs, it was DEOs, it was DTOs, all doing nothing. They were just supporting, the database. So I got the bright idea, before Node.js was even a thing. Let's try running JavaScript on the server. Then the client and the server are speaking the same language. And all that did was make my life even harder, because it turned out that I was doing the same marshalling I was doing in Java, but now I got rid of my static typing, so I can't tell what the heck is going on anymore. And I don't find the errors until runtime. So that was a bad idea. So then I settled on, a different approach where we were trying to create reusable servlets, reconfigurable servlets. And, we were trying to use, configuration WebXML, which was pretty nascent at the time. And because it was configuration based, we really needed to do streams of maps rather than objects. And this actually worked really well. And we eventually pulled the configuration out into its own files. And that turned into the platform. And that platform, the first version, gave the team a 100x performance boost. This is a crazy number. We went from an 80,000 line code base to 4,000 lines, and the number of function points went up considerably. So when we ran the math, it was a 100x performance boost. What actually happened was, we realized that with this technology, we could take 3 engineers, 3 months, and do what was considered impossible projects and get them done on time and on budget. First time it ever happened. This company was particularly used to everything being over budget and over time, and requiring very large teams. So this technology ended up crushing all competition over the years from there. First in, the competitors we had nipping at our heels, at this company, and then we had internal teams try to take this out. They tried to fight it, and I have so many stories here. There's a lot of really good stories. If you want to hear them, ask me afterwards. One of them was even the first version of this technology, the first product that we built. It lasted over a decade, and then a competitor paid IBM to shut it down. That was how they got rid of it, when IBM was kind of giving up on healthcare. So it's funny how this works. All right, so with that in mind, what is convergence? Well, it's a fundamentally new way to access databases and process data in Java. Well, it's fundamentally new to most of you. I know at least one person in the room who's seen it in action, but and it eliminates object mapping entirely by using a map to represent the record. Now, when I say object mapping, I mean object mapping. I hear a lot of people say, well, I'm using Spring JDBC, so that means that I'm not using an ORM. Well, even if you're manually mapping it, you're still bringing it into an object, and you don't need to do that. It's a waste of time. Now, bringing into a map means that you're dealing with key value pairs, which does have some consequences, but we're going to talk about why those aren't a big deal. So we focus on managing the streams of data, avoiding direct manipulation of the data. Like with the JavaScript, right? If we're directly manipulating the data, we've lost some of our static typing. That seems like a problem. It's actually not, because what we're really doing is redirecting the streams where they need to go and then using them. And the end result is this drastically reduces code sizes, results in vastly higher performance over existing technologies, and becomes a platform for unlocking new technologies. We'll unpack all of that. All right, so I blathered on. Let's look at some actual code. So here's how we query the database. We first initialize a database management system, DBMS object, passing in a data source. If you're not sure where to get your data source from, we'll go through various ways in the presentation. And then we take our query and we wrap it in a query object. And then we execute that query. And we get this iterable of JSON objects as a result. Now, the JSON object is actually implementing map in Java. So anywhere you can use a map, which is generally anywhere you can use an object in a lot of APIs, it will work. And iterable is important because we're going to do a little printout of the results. And you can see that we're using the enhanced for loop. Well, that works not because it's a list, but because it implements iterable. So even though we're streaming the data, we're able to use the enhanced for loop. So we'll print it out, and what do we get? Well, we get the results in JSON. So even though it's a map, it'll print it out in JSON, which makes debugging so much easier. You have no idea. So, okay, great. We printed out some data, but what can we do with that? Well, what we do is we redirect the stream where we need it. In this example, we're exporting the data to a file called example.json. And then we're writing the data to a JSON file by initializing a new JSON output. So that's the format we want. And then we're writing to the target, in this case, a file target, and we're just giving it the stream results. And it takes care of giving us a file that looks like a giant JSON array. Although if you parse it with Convirgance, it will stream it one record at a time. We can easily change that to a different format, like CSV, just by initializing a different output object. So now, different output object, and we'll write it to a different file because it's not JSON anymore. And there you go. With one line, you have got a completely different format. And what's cool here is you'll notice that we've used the stream twice. That's because the iterable is a setup, so it will rerun the query the second time you try and use it. All right, so we've selected the data. Now how do we put it back in? So we need to read data from a file, so we'll actually put a file source around our example.json. And then we will use a JSON input. So we had JSON output, JSON input to read the file in. And that gives us the same iterable of JSON object. All right. And so now we need to prepare the insert query. Same thing, we connect to DBMS. And here you'll notice that our query has changed slightly. There's now these colon names in here, colon name, colon devices, colon pets. Those are named bind variables. And Convirgance is going to take care of automatically injecting those safely under the covers so that the optimizer does what it needs to do. And also, I should point out, those are the same values we selected earlier from the table. So bulk load data, we just do a database update, we give it a batch operation, and bam, we've just inserted one record, 10 million records, it doesn't matter, right back in the database. All right, this is too simple, isn't it? It's like, okay, cool, but it's so simple. Yeah, it's simple. But the trick here is that this does work as you start scaling it up. So here we have a web service as a servlet. We've got our URL pattern up there. And you'll notice that we're doing a Jindy lookup in this case to get our data source, right? Because if you're using Java EE, typically you're going to set it up as a Jindy. You can get it any other way you want, but this is pretty typical for a servlet. Now our query is all customers by zip code. So we've got a bind variable here, zip code. And then we are, of course, binding the request parameter for zip code into the query. And again, we are able to initialize the JSON output, write it out, and bada boom, bada bang, there you go. You've got your web service, just like that. And the output is just a wrapper around get output stream for the servlet. Okay, let's do it in Spring. So data source in Spring is typically handled by an application properties file. So you can auto wire it in like this, really easy. And here we've actually moved the SQL into a file in our project. So in our resources directory, we're keeping the SQL there. That lets us use our IDE to color coding, autocomplete, everything that we want out of treating a SQL file as a first-class citizen, which also lets us get a lot more complicated with the SQL. You know, try putting a 50-line SQL statement into an annotation sometime, and you'll appreciate moving it to another file. So same thing, we just set the binding. Binding's just coming from the URL, right? The get mapping up there, and then passed in. And then you'll notice that we've returned the results of the query, so the iterable JSON object is coming back. That's because Spring, remember how I said that iterable and maps are handled by a lot of APIs automatically. So Spring thinks it's just a list and a map, and so it translates that to JSON by itself, so we don't even have to do it for it. You can, if you want, you can grab the output stream and do it, but you can just let Spring do it. All right, so let's talk about performance for a moment. So this is pretty cool, but why, right? Why does this matter? Well, here's a very typical JPA endpoint. It's our zip code example again. There's a huge performance problem here. I know, it's like no code, but like there's a huge performance problem here. Does anyone know what it is? Probably not, because it's right there. That list is a memory reservoir. Depending upon how big it is, it can cause a lot of problems. Well, what do I mean by that? Let's make this bigger. Okay, does anyone recognize this diagram? So this is what the garbage collector in Java looks like. You have two young pools, and they switch back and forth on which is active. And then you have the old pool for garbage collection. And here, we will reset this and watch it work. So when you are running your code, you're going to allocate up some number of records, right? And we'll look at the left there. So it's allocating up some number of records, and then once those records are used, right, deallocates. And this being the young collector, when the current active young space is full, it will copy the active records into the other pool, and the end result will be more space to do things. But if we keep allocating, so we have a very large set, what happens if we allocate one more time? Any guesses? Because there's nothing that can be garbage collected when it allocates one more time. So it's going to have to move it into the old garbage collection. Now, old garbage collection, the difference between young and old, if you're unfamiliar, is that when the young switches, it does a copy of what's still alive, with the idea that most of it's going to be dead. So that means that there should be fewer copies into the other space, and then it can just reallocate everything in one fell swoop. And that's very fast garbage collection, often exceeding CMalloc in terms of performance. But if the young collector doesn't have enough space, it's going to go over into old collection. And what's going to happen if we let this run is that even though things are deallocating, the old GC won't collect until it gets full. So you're carrying all that memory. If you want to know why you have to have big servers to run Java, this is why. Because you're carrying all that memory. And this happens in other languages too. I just saw a post on X the other day, someone wondering why their memory on Node.js kept going up, 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 and then eventually would come down, and up, 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 down. Same thing. But you'll notice on the right-hand side here, what's happening with convergence. You guys see that? There's only one active record at any given time because we're streaming it. So we do everything possible to the record, then we get rid of it, and we're done with it, on to the next one. And so that's friendly to the garbage collector. We're not thrashing it so hard. You know, in just the time I'm talking, we've done 8 stop the world and an old collection, right? It has to stop the entire program and compact everything down. And so the ORM is killing your performance and you don't even know it, while convergence, with very little hardware memory, it'll just keep going. All right, so that's bad. How bad is it? Well, it gets worse. So let's dig deeper into this example of ours. You might have noticed that it was customer DTO, but down here we have customer coming back because we have a customer repository and entitlements repository. The customer is coming back by zip code, but then the entitlements are by customer. And then here in our customer service, there's a translation from customer to customer DTO. Now, you can get JPA to do this for you. That's not the point. The point is that the code is expressed here so that you can kind of see what's happening. And we can see that these lists are memory reservoirs. And critically, there's a transformation happening right here. And what do I mean by transformation? Well, it's wrapping the customer record, taking that data, and then merging it with the entitlements results for that customer. And by the way, that's potentially a ton of database queries, right? So that's really bad. However, for this example, we're going to assume that JPA did its job as caching the living starch out of those entitlement requests. So we're not actually doing a whole lot of database queries, just to keep it fair. So then with those merged, we then are able to serialize something that looks like this with a hierarchy of data. This is good. We want to do this because if we do this on the client, that's a ton of requests back to the server, right? So we're saving time on the line and we're making this more efficient. But on the server side, we're not very efficient. And here's our memory reservoir. Now, this has a number of further effects. So this little bucket here, this is our memory reservoir. Just with the one from our original example, right? Convergence is getting done so much faster because it's not loading everything into memory. If we start adding transformations in there, watch what happens here. So while it's still loading, convergence is writing, convergence is writing, convergence is writing, and convergence is done before the first record has even been written by the ORM. How many times have you heard, well, you can't do anything about latency. Latency is just there. That's not true. You can balance the system. Remember that engineering? We balance the system so that everything is utilized to the best capacity that it can be. So we're getting it done as fast as possible. And this gets worse as we add more. And if you want to, we have this online. You can play with it. And it gets crazy. So that's bad. But I should mention how transformations and convergence work because you just kind of saw them, a T there and it just did a thing. What's going on? Well, in convergence, we would run this query here. This query has a join on customer and entitlement. Now this is bad. Anyone want to guess why this is bad? Or at least traditionally considered bad? Well, because you have a one-to-many join, so that means your customer data is going to repeat over and over and over from record to record, which ORMs can't handle, right? So that's bad. In convergence, what we do is, okay, we set up our query, we get our results, and then we identify the fields that are unique, and then we say take everything else and put it in an array called entitlements. So this will buffer up the data, and then we say transformer, here's my iterable, give me an iterable back. All right, so it extends the pipeline. And the end result is the exact same data, but now we've utilized the database more efficiently and more effectively to get what we want. Okay? But it gets worse. So here's the thing. That the transformations are happening between the memory reservoirs. So in practice, when the memory is moving from the main memory, right, all that stored in RAM, it has to go across the bus, L3, L2, L1. Now, when it gets to L1, it actually gets processed, and you'll see what's happening. 1, 2, 3, 1, 2, 3. Convergence is doing everything on that same record while it's still in L1. But the ORM is only doing one transformation, and there's potentially so many records that it can't keep it in cache. It has to push it all the way back to main memory and keep doing this loop. So you're streaming the memory every time you want to, for each transformation. So we're just getting to the second transformation. Got to make it all the way around. Yeah, it's going to take a moment. And you can see, right, the convergence approach is far more efficient because we're using maximum utilization of cache, ideally L1, because L1 is the CPU's memory. That is where you get that advertised performance on your CPU. So 3 point whatever gigahertz. If it can't fit, then L2 is about half that speed. L3 is about half that speed. And then often main memory is about half that. So that's, 1/8. And really you have wait states in there too. And you might have noticed that this was completing all of the calculations while this one was just sitting. That's because there's a cost to evicting and pulling in new data on the cache line. So it really is that much faster. All right. All right, so I'll leave that as, we've looked at enough performance stuff, we get it. But you can undo this performance and convergence in one easy step. If you'll notice, there's an array list right in there, and we're putting things in the array list. And yes, you can return that array list as your iterable, because array list implements iterable, and convergence will handle it. But you've created memory reservoirs, which mean you are now paying the cost of having memory reservoirs. So don't do that. All right, so that's performance. Let's talk about productivity. How does this make you faster? All right, so let's compare convergence to MyBatis. All right, in this example, we're going to pull from the customer table, and we first need a file that describes the customer table and a query, or any queries that we want set up. In this case, we have a get all. That's all we need. But we have to have this whole description of the table. So then we have the MyBatis config XML where we line up our customer XML, and the rest of it I don't have a huge problem with. That's just database connection information, so that's fine. But the mappers below, right, we have to have a whole nother file just to list them. Then we have to have our POJO. And yeah, this I kept getting smaller as I tried to fit more on the page. This is just getters and setters, right? I mean, this is what we have to do. Now, some of you might be saying, Lombok, hold on, we'll get there. So then we need an interface that will represent the mapper. And we had the one query get all that it will implement. And MyBatis will generate this for us. Cool, it finally did something. So now we have a program that attempts to export CSV to a file. So we have to load the MyBatis config, run our get all query, and now we're going to use Apache Commons CSV printer, which has no idea about what the structure of the data is because it doesn't know our objects, right? So we have to print out the header ourselves, and then we have, this gets me. We have to marshal the data from the customer object into an array just so we can print it out. What is the point of using an ORM if we're just marshaling the data all over again? Fun fact for you. The mapper code that generated by MyBatis is pretty much the only thing you have to do in Convergence. And even that's debatable because the query is in the XML file. So let's look at the Convergence example. It's this, you've seen it before. Big difference is we're using Convergence JDBC here. This is a neat API where it analyzes the URL and will actually go to Maven Central and pull the driver automatically. So you don't even have to have the driver installed, it'll get it for you. And then it'll get you a data source so that you can query the data. And we query customer, we return the records, you get it by now. But if you pay attention, right, everything was hard-coded in the MyBatis example. Everything here is just strings. We could practically set this up with passing these in from the command line. The URL, the username password, the query, the output file. We could just send this configuration in and get any table we want. No additional configuration required. So this is 9 lines of source versus 87 lines of source in NCSS form so that we can compare them. And that's a huge decrease. On top of that, one class versus 3 classes, it's 89% less code. We're not even counting the XML files at this point. It's 66% fewer classes. So this is just simpler and easier to do at the end of the day. And by the way, if anyone remembers their Mythical Man month, every line of code has a cost. There's only so many lines of code that engineers can produce, debugged lines of code they can produce per day. Yes, they can sprint and do few hundred lines of code, but then they're debugging that over time. It averages out to a very small number, like 10 to 20 lines per day. So fewer lines of code means greater productivity. All right, fine. So let's use Lombok. So we found an example of Spring MVC, Spring Boot, JPA plus Lombok, and we've got the controller here, and there's the other files under the controller: the product service, the product repository, and they don't have much in them because Lombok, right? But you'll notice that even though most of the logic is actually in these other files, the size of this ends up pretty similar to, yes, denser logic. You can see the queries going on, but it ends up of a similar size. Okay. This should be an easy win for ORMs, because this application, you'll notice that this is a save product on a post mapping product. This is CRUD. Create, read, update, delete. That's how we structure most Spring applications. So if ORMs were ever going to win, they'd win here. And they didn't. 35% less code, 59% fewer class files. And we left it in the idealized CRUD form. We didn't redesign it of how it would actually work in real world cases, because CRUD breaks down in the real world. And we'll get into why. All right, well, 35%, that's a nice win. But come on, you're telling me that I should start using a completely different API that looks just way too simple and not industry standard, just for 35%. Okay, so we went and we looked at the Spring MVC Pet Clinic. We initially tried to do the port same as we did the other one, and we realized this is a classic 3-tier architecture, and it was just so painful, and it wasn't really proving anything. So we rewrote it in our Convirgence Web Services API, really framework. And the Convirgence Web Services API, we were able to modernize it as more of a horizontal architecture. And the end results were interesting, right? So there were 12 time leaf pages in the original Pet Clinic, and there were 12 JSP pages in the port. Okay, no real win there. There was 15 endpoints or services in the original code, and we had 12. Now, I'm not counting any that in Spring that were kind of meaningless, didn't do any data, like the welcome endpoint or the error endpoint. So we just got a little more efficient with services. And okay, that's a nice win. But would anyone like to guess what the drop in code was? So we had 35% in the last one, 89% before that. Any guesses? We went from 540 lines of code to 0. What? 23 classes to 0 classes. We dropped all the code. Well, how do we do that? And this is just all the Java code, I should say. But we dropped all the Java code. How do we do that? Well, the Web Services API, we'll get into it in just a moment, is configuration based. So all we had left were config files, because this application was so simple. Normally we design for the 80-20 rule. 80% you want to be as simple as possible, so you don't worry about it, and then the 20% is where you focus your energy. Well, this one didn't have a 20%, so bye. So let's talk about the platform. So most of what we looked at in terms of code was the base convergence library, but it's enabled a lot of things. Convergence JVC, which we talked about briefly. If you do any business intelligence, we provide an API that lets you do business intelligence directly in code. So, well, we'll get to that. Storage, it's still coming along. The idea is it's local database stuff. and web services, the no-code, low-code, configuration-driven web service solution. And we're also working on a CLI so that you remember how that was configuration-based for the CSV. We want to let you do file format conversions, imports, exports, all that really easily. So Convirgance JDBC, you saw this before, right? We just say get data source and give it the URL, username, password. It goes to Maven Central, downloads it. You have a source. But it also does other things like you can query the database schema hierarchically. So here we ask for we get current schema, then get the table from the current schema. And then you'll notice table implements iterables, so we can actually just print out all the records in it. Or we can export it to a file. And then we can also get a select from it, modify it, and use that query. So it does all that stuff. OLAP, so if you have used Cognos, MicroStrategy, Power BI, Tableau, Looker, any of those, you've probably paid a lot of money to do that. And you know that you structure your data in this star schema. And these star schemas don't play well with ORMs because the results are very arbitrary. You get whatever columns are selected, and that doesn't fit well. Some people try to create super wide objects, with every possible result. That doesn't work very well because they'd have to detect what's null, and sometimes the data is actually null. But this API, you give it the structure, and it will generate you the necessary queries, which you can then run in Convirgance. And it looks something like this. All the from the config file, we pulled down the dimensions and measures, and then on the client side, we can select them. And so here's total sales and units sold by franchise name. And then, this can be updated, however, with, whatever query we want. So I forget what gets chosen here by something. Come on. All right, by franchise name and category. You get the idea, right? So whatever OLAP query you want to run, it'll generate it for you. We just send up the selected dimensions and measures. There you go. All right, so Convirgance Web Services. So this is really that servlets with pluggable pipeline components idea. These are some of the things that get plugged in, but let's actually look at some code. So this is a full configuration file. This is our zip code example again. And the way that this works is that this request parameter here says, okay, I want zip code. And so I'm going to take zip code and I'm going to put it in this JSON object. And then I'm going to bind it to a query. So we have a binding here. We're plugging in query binding. And notice this is pluggable, so it doesn't have to be a database. We're using the GIND lookup. And then we're saying, okay, give me the customer by zip code. And we're binding from that object that we'd created in the parameters. We're binding it there. And then we can optionally have transformers after that, which we don't in this case. And then we select what output we want. It's very common that we would have an interface where the user interacts with the data, and then they'll say, oh, well, we want to work with it in Excel. We just copy the service, change the output to CSV output, bam, we're done. And so this is very fast and easy to create these, even though, it's XML, it looks clunky. We are looking at, more dense versions of this, but this actually works just fine. And it's a Spring XML file. So amusingly, our Spring port was still Spring. And of course, we have to go the other way around with insert. I won't go through this in as much detail. Basically, I have to figure out where we're getting the data from. The origin could be the request body, could be a parameter, then the format, JSON, CSV, whatever. Any transformations we want to do on it, and then bind the inserts. And we also support sequences to inject the keys and return those back. So again, we were able to do the inserts as well. So this shouldn't be possible, right? If any of you have read Mythical Man Month, Brooks said there's no silver bullet. There's no single development, either in technology or management technique, which by itself promises even one order of magnitude, a tenfold improvement within a decade in productivity and reliability and simplicity. I'm claiming we've done up to 100x. Now, Over the years, it's decreased. I've measured 20x in some cases, but it's always been very high. It shouldn't be possible. The reason is we've left a ton on the table because of the object relational impedance mismatch. This isn't something I made up. There's the Wikipedia page if you want to look it up. It was first noted by this guy, Ted Neward. Some of you might have seen him at conferences. He started talking about this in 2004 and then wrote his article in 2006 on the Vietnam of computer science. He said they're a quagmire that's simply too attractive to pass up, a siren song that continues to draw development teams from all sizes of corporation, smashing them against the rocks with spectacular results. Now, Ted isn't the only one talking about this. Laurie Voss, creator of NPM, also opined on this in 2011, and there's more, but I'll stop here. Laurie's take was very interesting. He said, ORM initially are simpler to understand, faster to write than SQL-based code. So we're thinking, okay, we can have developers who don't have to understand the database. And the efficiency in the early stages of the product, he says it's adequate. It's not a big win, but it's adequate. Fine. The problem is these advantages disappear as the project increases in complexity. The abstraction breaks down, forcing the dev to use and understand SQL. And what does that mean? Well, we start having to put SQL into annotations, and then those annotations get too big, and then it gets too complicated. We have to put it into a stored procedure. And now your logic is spread between your application and your database. And he said, entirely anecdotally, and I happen to agree with him, I claim the abstraction of ORM breaks down not for 20% of projects, but closer to 100% of them. So what's the cause here? So create, read, update, delete. This is what we model everything on. CRUD is for loading databases. It's not an access method, but we treat it like it's an access method. Oh, we're just putting something in the database and we're getting it right back out, right? Yeah, but relational databases are about joins and filters and aggregates and things that process the data in a useful manner. We can ask questions of the database, and we can't do that with object graphs. So when we did this is not CRUD, right? We're pulling data from multiple tables in order to get our answer. And the problem is that CRUD implies no exploitable relationships between data objects. And that's the problem. Now, there are cases where you're okay with just CRUD. If you're building an online forum, fine, you can use a document or object database. But I will point out here, DB4.0, Carl, he perfected the Java object to table approach in his own database. You could take any Java object and store it and bring it back. They're out of business. They're not around anymore. And apparently the market didn't agree that it was useful. And so that should tell us something. And yeah, you can use convergent storage when that's ready. Here's the problem. ORMs are modeling the wrong thing. If anyone's written a video game, right, you set up a stage and you create backgrounds and you have scroll offsets, and then you have actors and you figure out the collisions between them and the pathfinding and all that stuff, right? And so we model all these objects in memory and we create video games. That's cool. Are there interactions between the objects when we're modeling them in ORM? I mean, we're certainly working the relationships with them, but the relationships are all historical. They happen outside of the system. The user is making those decisions. Now, there's some cases where a back-end process needs to run, but usually it's just a delayed computation more than an actual interaction, right? And so we're building all this model to represent a simulation, and we're not doing a simulation. So we're wasting time and energy. And what we should be modeling is the movement of the data. So object graphs modeling a simulation. Relational sets represent historical interactions, not active interactions. So let's look at this in a different way. Which is the source of truth, right? The Highlander principle applies when you talk about source of truth. There can be only one. Now, is the relational database the source of truth? Or is your object graph the source of truth? Well, if we choose the object graph, we eliminate the analytical capabilities of the database. We can't use the database for its intended purpose anymore, and you might as well get rid of it. Because the source of truth is your object graph, right? That's painful, and no business that I know of has ever made that choice. If we choose the relational database, we lose something. Schema duplication in the POJOs entities that we create to map the data in. All right, schema duplication is gone. Hard-coded access paths in DAOs. And transfer objects serving no other purpose than serialization, right? We load the data into the DTO and then we serialize it back out. These don't feel so painful to lose, right? If we have to make the choice, losing the ORM is better than losing the database. All right, in summary, Convirgance breaks the object relational impedance mismatch because it treats the relational database as a relational database. It's easy to use and understand, right? What we do is very hard, but our job is to make it look easy. Code sizes dramatically drop and become easier to maintain. And this has come up a lot. Well, you know, static typing and, you know, all this code spread. No, your code sizes drop so much. Everything's right at the edge. You can see it. You can maintain it. It's so much easier. System becomes configuration driven rather than code driven. This is how you continue to keep your code size small, because it keeps folding over on configuration. And Convergence enables new technologies and approaches, right? ORMs were locking out a lot of things that we didn't realize. For those of you in healthcare, if you've ever tried to build an object model, and by the way, the government has tried to do this, if you've ever tried to build an object model of patient data, you'll find it doesn't work. There's always exceptions. There's things that you're doing that don't fit in the government's model, and you have to be more dynamic. So in Convergence, it doesn't care, right? You can transform them into any structure you want. When I worked in a healthcare measures engine, we would pull data from every table that had patient data into it and turn it into one giant JSON object, which we would then be able to run through an engine that would compute everything about that patient. And that approach became shared nothing because one patient doesn't affect another patient. So we can put them on as many CPUs as we want and get it done faster. And these technologies, they create a strong competitive advantage, right? You get your work done faster for lower cost with fewer people, and you can do stuff that your competitors can't. Your competitors will try to follow, don't get me wrong. They will try to hack something up and make it look as good as what you have. So you just add another feature, and you add another feature, and you leave them in the dust, right? So we're getting to the end here. This is all very new to the market, right? It's proven technology, but it's only been in private corporations. So this is now new to the open source community. So how you can help, use Convergence, try it out, see if it works for you. Spread the word, talk about it. Hey, there's this really counterintuitive thing, Convergence, you know, it seems to work really well. Send us your questions and feedback. We want to hear from you. We want to keep developing this and getting it to where it needs to go. That top link there, that's a discourse forum we set up. Just to make sure that you know, we have a public place for people to ask questions. There may also be an r/convergence on Reddit that may or may not exist. And then you know, if you want to email us, that's fine. Use a contact form on our website. However you want to do it, whatever you're most comfortable with. And let us help with your projects, right? We're in the phase where we're not trying to make money right now. Now, money's good. I like money. Money keeps the lights on. But our goal is to get the technology out there and adopted. So if you have a need, call us. We'll come in, we'll talk to you, we'll help your team understand it, we'll get you on your way. And if you decide, hey, we want you to stick around and consult with us to help build this thing, fine, we'll get you a really good deal on it. We're not trying to really make money right now. But you know, if you want to throw money at us, you're welcome to sponsor us. So that's all I got. Questions?
Do you have it? So I've seen you post the GitHub URL to it. That's where the open source.
So so if you go to convergence.com, there'll be actually a GitHub link right there in the corner, but it's github.com/Invirgance open source. All of our projects are there available, and you know, all that platform stuff you were looking at. The web services APIs will be out soon. They're pretty much done. We just haven't gotten to, in time for this talk to get them out the door. And we have other things like there's plugins we didn't talk about for other file formats, like there's a YAML parser in there as well. So yeah, it's all available out there. And convergence.com, you'll find, you know what, I can just. So this is all of our documentation here on how to use convergence, and you can learn and figure out how to do things. And we're continuously updating this with the new APIs as they're coming out.
Visualization that you did for the combining tables. Do you have some idea to do this for the people human work? So I mean, this is API that you're showing. It's not complicated, like after development, right? Why don't you do this like for development and for managers team for a big company? Because what I'm working with, there's like two different group of people, right? One can develop and see this JSON, but the managers, they want to see this JSON as well. So that can be like additional feature, like maybe, right? So just to have the table. If you want to read from the table, you just have the visualization. You're doing this on the web, and you can export this JSON in your file.
So the question, if I understand, is can you have APIs to allow direct access to the data, a web access to the data? Sure. And the Convergence JDBC API, you might have noticed, provides that navigation of the schema. We're working, so phase 2, we're almost there. We're working on software as a service type of solutions that will let you do exactly that. So you connect your databases, and then you can start storing queries. And what's that? Yes. So AI is funny, right? So the short answer is yes. AI will have its place in the future, but we see AI a little bit differently than most people do. Everyone thinks, okay, well, we'll use AI to code, and AI can't code. AI treats software as another spoken language like English, and so what it's doing is regurgitating tutorials and other things, so it looks really impressive. And it does make certain leaps and jumps, but when it starts getting complicated is where it breaks down, because code is actually symbolic logic, right? And the AIs are not tuned to understand and think about symbolic logic, and they also don't have, they have reasoning capabilities to some degree, but they don't have the ability to make insights, right? So the AI doesn't learn something from what it did and then apply it broadly across other things. Anything it does learn lasts the context window, and then it's out. And so what you tend to see is that as the AI codes, eventually it kind of reaches a level where it starts losing the plot and starts doing some wacky things and imagining APIs that don't exist. And like I spent some time on CSS with an AI the other day, and it did great at the beginning, and then it just couldn't get to some basic tabs that I wanted. And yeah, I was just trying to do some CSS at the point.
Database, when you're checking with the with the UI and like, hey, go to this database, get me this one. Like, for example, you're just showing from the shopping and like the top setup for this one.
Well, and
who did like the big profit?
And AI will do that to a point, but you start asking it complicated queries and it will get the query wrong.
Can it be combined with the convergence?
So can the AI be combined with convergence? Well, at the end of the day, the question you're asking is really SQL. So convergence can run it, but if the AI can't express it in SQL effectively, you're not going to get there, right? Right. But on the other hand, if you want AI to summarize something, if you want to think in terms of like human expression, deliver reports on a regular basis, those are things AI is very good at, and ways we'll be integrating it in the future. Mm-hmm. Yeah. Cool. Other questions? Yeah.
In convergence, or you use convergence to solve the memory
So convergence solve. So let me make sure I got your question right. So you're asking, is the memory problem caused by convergence or solved by convergence? So,
Convergence, or you try to use convergence to solve the memory problem.
can you use convergence to solve memory problems? Yes, yes, you can. So because of the way convergence streams data, anywhere where you replace, and you can do this, right? You can inject this straight into your existing applications. We saw it in, Spring and servlets. You write that service in convergence, and suddenly you don't have the memory problems you had before using the ORM. You can still have the ORM there. Convergence isn't going to lock you out, but anywhere where you have problems, yeah, just use convergence and your problems will go away. Does that answer your question?
And then the memory problem occurred under any circumstances or just some situation it occurred.
So is the memory problems in some circumstances or in all circumstances? Well, that's a tricky question, because as long as your code base stays small enough and your data size stays small enough, you probably won't notice the memory problems, because modern computers are stupid powerful, right? And we don't all run on Raspberry Pis. Some of us do. And so, for a small enough application, it will work. But will it be faster and more memory efficient in convergence? Yes. One of the things that's critical to understand, that like cloud providers, they want to sell you more hardware, more virtual hardware, right? So they want you to use these things. They're trying to sell everyone on Node.js, because you have to have one VM or container per Node.js instance. And so they don't care. You just use more memory, more CPU, they'll just sell it to you. You use convergence, you need less of that across the board. So you just have to worry about your duplication, but then maybe you could run multiple applications across a couple VMs and save a lot of money, right? Okay. Other questions?
Yeah.
Yeah.
So I put on analytics. I always see myself and developers go shoot for Python, learning that on the development side. So why JSON objects in Java? Why not Python for even lower?
Right.
Theoretically lower lines of code.
So the question is, why not Python rather than using Java? Because Python is fewer lines of code. And actually, your question is a good one, because a lot of data engineers will use Python because it does a lot of these similar types of things, but Python doesn't scale. So one of the things that there's some clients I wish I could talk about, where it's like you start pushing it, and it's funny. There's instances where someone wrote a measures engine, a healthcare measures engine in Python. Oh boy, we did everything we could to make it fast enough, and there's only so much you can do, because Python is just incredibly slow at what it does. So when we sat down and we founded Invirgance, we said, okay, what is the current technology landscape? Is Java the right solution, right? And we looked across the board, and everyone's talking about Rust and JavaScript on the server and yada yada, and they're saying this is so cool, that's so cool. But it turns out that when you lined everything up, performance, capability, APIs, everything, Java was still the superior platform. And don't get me started on the instability of C#. Rewrite your code every 4 years. Thanks, Microsoft. So Java ended up still being the right solution. Now, what's cool about convergence is that, as more and more solutions develop, this gives you Python-like capabilities in this high-performance space, right? So you have that nice and easy. Let me get the data. Let me transform the data, send it wherever I need it to go. And so you're not stuck with Python anymore. So when your data engineers are like, I can Pythonize this, you're like, whoa, slow down. Okay, that was very cool. Now let me translate that to convergence for you.
So SQL file, can that be replaced by a Python file in your subquery?
So I don't see any reason why you couldn't do it. Right now, we don't have support for, doing it with Python like that. But out of the box, you could just turn that into a piping the output of the Python, and then the source you just read from the system in, and now you can read it with convergence and do whatever you want with it. Just keep in mind, right? Python's great for the one-off. You just need to get the data from here to there once. Cool. If you need to do it a lot, you're still putting the big blocker in your system. Mm-hmm. Yeah. All right. Any other questions? Going once, going twice. All right. Thanks, everyone.